Hello everyone, Param here. Today I'm walking through the Conic 4 game project, including the front end, back end, and some AI and machine learning optimization techniques. We'll go through the code step by step, and then we'll push the project to GitHub so it's publicly accessible. Let's start by opening the project in VS Code. For the front end, I'm using Angular. You could absolutely build this with React, Vue, or even plain TypeScript, but I prefer Angular because it gives you a more complete framework structure out of the box, which helps a lot as the project grows. Here inside the source folder and then the app folder is where most of the application logic lives. In Angular, source/app folder is typically the main place where you'll find components, services, templates, and other core application code. Now let's look at the components. In this project, I have components such as board, cell, and game stat. The board component represents the main Connect4 board and act as one of the central UI pieces in the application. If we open the board component, you'll notice decorators like input decorator and output decorator. These are used for communication between parent and child component in Angular. Input decorator passes data from the parent into the child, while output decorator lets the child emit event back to the parent, typically using event emitter. Now let's take a quick look at the game stat component. This component is responsible for displaying the current game information and some lightweight AI insight. It receives the current game stat from the parent component using input decorator, along with the currently selected agent and search depth, and it sends changes back to the parent using the output decorator and event emitter when the user selects a different AI preset or depth. So in this case, the component is not just showing status like whose turn it is, who won, or how many moves have been played. It also acts like small control panel where I can switch between different AI strategies such as random, heuristic, minimax, variant, and DQN, and also adjust the search depth for the algorithms that support it. Another nice part of this component is that it computes readable metrics from the raw game state. For example, it derives things like move count, win probability, AI mood, vantage label, best move, and evaluation score. So instead of showing raw backend data directly, the UI turns that into something much easier for the player to understand. I'm also using Angular lifecycle behavior here through the ng on changes, which lets me react whenever one of the input value changes. In this example, I'm mainly logging incoming values, which is useful for debugging and make sure the selected agent depth and evaluation data are updating correctly when the game state changes. So overall, the game stat component is doing two things at once. It gives the player a live summary of the match, and it gives them control to experiment with different AI agents from the same interface. Now let's look at the game service, which is really the bridge between the Angular UI and the Python backend. This service is marked with injectable decorator and provided at the root level, which means Angular can share one instance of it across the whole application inside it, I inject Angular's HTTP client, which is what I use to send requests to the FastAPI backend running on local 8000 port. One thing which I like here is that I'm using Angular Signal for state management. So instead of manually passing data around everywhere, I keep the main game state, loading state, and error state inside signals, like game state is loading and error message. Then I drive values such as the current board, whose turn it is, and whether the game is over using computed, which is automatically updates whenever the underlying signal changes. The core API methods are pretty straightforward. Start new game function sends a post request to create a fresh game. Make move function sends the selected column and current player to the backend, and refresh game function retrieves the latest server-side state. I'm using first value from here to convert Angular's HTTP observable into async/await style code, which makes the control flow easy to read in this service. Another interesting part is that this service doesn't just fetch data, it also reads it. Function like evaluate window function, evaluate board function, and enrich game state function let the frontend compute extra insight such as position score, evaluate score, and best move if needed, so the UI can display more explainable AI feedback instead of just a raw board state. So overall, the game service acts like the central state and communication layer for the frontend. It talks to the backend, stores the latest game state, and gives the component a clean, reactive interface to render the board and state. Now that we've seen how Angular sends and stores the game state, let's move to the Python backend in main.python. This file is the core FastAPI application. It creates the API, enables cores, so the Angular frontend on localhost 4200 can talk to it from the browser, and defines the main request and response models using Pydantic, which gives us structured and validated data flowing between the frontend and backend. The main endpoints are pretty simple. One endpoint creates a new game, another returns the current game state, and the most important one handles a move. When the frontend sends a column choice, the backend validates it, updates the board, checks whether the human has won, and if not, immediately runs the AI move and returns the updated board back to Angular. What makes this file more interesting is that it combines regular API logic with game logic and AI logic in one place. So, in addition to handling HTTP requests, it also contains helper functions for creating the board, checking winners, scoring positions, and choosing the AI move using strategies like random play, minimax, or DQN inference. So you can think of main.python as the brain of the backend. Angular sends the move, FastAPI receives it, the Python game engine updates the match, and AI chooses a response. And then the new game state is sent back to the frontend. I'm pushing the project to GitHub. I initialize the repository with git init, stage the files with git add dot, create a commit with git commit -m and then a comment, and then push everything to GitHub with git push origin main. And to run the backend, I'm going to run this command, which is uvicorn main colon app with the reload switch. And also the GitHub repository is here. So here is the Connect for game repository, which you can go and clone the code. Let me run the game and show you how it works. So here we can go with the ng serve to run the Angular, and as you can see we can go to port 4200. For the backend, I start the FastAPI server with uvicorn main colon app, and the switch is reload, which gives me live reload while I'm developing. As you can see, this is the command and it says application startup complete. Port. This is the Angular side and we can play the game. As you can see, so I am the red and the AI is yellow. Now, currently we are playing with the random and the search depth is 2 position ahead. We have 2, we have 4, 6 and the 8. I used to win this game very easily, but as you start training it, then it's kind of impossible to win the game. And the AI is gonna all the time because it gets smarter and smarter. It's gonna win here. If I come here, then it's gonna win on this side. So I'm gonna keep going on this. I couldn't. Oh, he's gonna win here. So let me move to this one. Oh, he's gonna win here. Let me block it. Now he's gonna win here, either or here. So I have to block it. Okay, here is getting so dangerous. Currently, much better play to win the game. I'm gonna go with this one. So if I come here, then it's gonna go here. So I'm gonna go this one. If I come here, then it's gonna win here. It's gonna be 4. I have no. So as you see, the AI is gonna win. It's gonna say the AI won. We can restart the game here. And yeah, so if you want to really lose so fast, you can pick any of this.